it should be a helpful video. Did anybody by any chance look at the video I sent out yesterday? You aren't just like got this on a Sunday night and said, oh, I can't wait for stats tomorrow. I got to watch this video right now. Nobody had that reaction. I'm so disappointed. At any rate, what? You had that reaction?
Yeah.
But you didn't watch it.
Yeah, just stop there.
No, okay. Well, you know, that's better than nothing. You know, that's okay. You will definitely want to watch it in preparation for this test. You know, I actually thought I did a pretty darn good job, and it's only 10 minutes long. So, yeah. So, all right. So we're going to. So there's two kinds of pictures, both using my little my curve, right? One here is from when I want to find a confidence interval, and other times, look at that, two of them pretty good. I want to find a p-value. So this is confidence interval. This is also known as a test of significance. Now you guys stop me if I make a mistake or if I'm not being clear. And like I said, I'm recording this, so it's going to be, I'm going to send it out as video. You'll have it to reflect on. Always a good idea to take notes as well. You know, that's helpful. All right. So one of the key differences between when I'm trying to find a confidence interval or when I'm trying to find a p-value is what goes in the middle. So with a confidence interval, I am starting with my data. I'm starting with the statistic that I got from the sample that I took. So if it's a mean, that is my x bar. If it's a proportion, it's my p hat. That is what is in the middle of the picture when I'm trying to find a confidence interval. Because that's the only really solid piece of information that I have is what I got from my data. And what I'm trying to find out is, let's just say, let's use 95% for example here. What I'm trying to find out is what is the lower limit and the upper limit of where the actual parameter lies. Based on my statistic, can I determine an upper limit and a lower limit, an interval for where I can have a degree of confidence? In this case, I'll make this 95. I want to be 95% positive that the actual population parameter lies between these two numbers. All right, so there's a couple things I need to do to be able to calculate that. One thing I need is I need to find the standard error, which is the same thing as our standard deviation, except it deals with the information that we actually have from our statistic. So that's, you know, where I can draw the lines and then figure out what my z-scores or t-scores are. So to find the standard error, if I want to find it for a mean, that is a quantitative variable, then that's going to equal the standard deviation that I got from my sample divided by the square root of the sample size. So again, you need to know what these symbols are, but S is the standard deviation of my sample, and N is the number of data items that I have. If I was looking for the standard error of a proportion, that is for a categorical variable, then that's going to be equal to the square root of p hat. That's the proportion I got from my data. That's the statistic, times 1 minus p hat divided by n. And one thing that is kind of interesting about that is that this is the same thing mathematically as the square root of p hat times 1 minus p hat over the square root of n. So in both instances, for means and categorical variables, for means and proportions, so quantitative variables and categorical variables, we are dividing by the square root of the sample size. That is consistent between both of these approaches. Still good? Okay, good. Okay, great. All right,
Wait,
let's.
Mr. Jenkins, I have a question.
Yes, please.
For the first drawing, when it says X bar and P hat, what's the difference again?
X bar is the mean, so that is for a quantitative variable.
Uh-huh.
P hat is the proportion, that's for a categorical variable. So they will never be on the same picture. You're either going to have a categorical variable or a quantitative variable. You're either going to do proportions or you're going to do means. It will never be this on the same picture, but I'm putting them here because they're both called confidence intervals.
So, sorry, X bar is mean of quantitative.
That's right.
And P hat is proportion of categorical.
That is correct.
Okay, thank you.
Okay, good. All right. So, so what I'm trying to find with a confidence interval is I'm really trying to find the distance between here and here. I need to find those two endpoints. So to find that, I'm going to take my mean. I'm going to do this for quantitative first. I'm going to take my mean, and then I'm going to plus or minus my t-score, my t-critical value, times the standard error of the mean. So the t-critical value, hang on one second here. Let me make sure I don't, let's go here. I want to just pause. Okay, good. So this t-critical value, I'm going to find that depending on what kind of a confidence interval I want, how big of a confidence interval I want. And the way that I do that, so in this particular case, I want a 95% confidence interval. So I'm going to look at this higher limit right here first, because I like to go here from 0 to here is 50%. And then from here to there is 1/2 of 95%. So that is 47.5%. So this spot right here, which is the upper limit of my confidence interval, is the 97.5 percentile. And I need to find out what that number is. I need to find out what is the t-score for that number right there. Everybody still with me? I'm going okay. Okay. So the way I'm going to do that is I'm going to go and pull up my calculator, and I'm going to go second distribution. And I know the percentile. I need to find the t-score. So I'm going to go inverse t, so that's 4, and I'm going to do 0.975, and then I have to put in my degrees of freedom. When I'm dealing with a t-score, I have to put in my degrees of freedom. So the degrees of freedom, which we annotate by df, is equal to n minus 1. So let's say in this particular example, I'm just making this up for this example, but let's say that n was equal to 20. That means my degrees of freedom is 19. So I put in here, comma, 19, and I close the parentheses, and I hit enter. and it tells me that my t-score at this spot right here, so my t critical value with 19 degrees of freedom is equal to 2.093. Are we okay there? Okay, so when I want to calculate the confidence interval, I'm going to take my x bar and I'm going to go plus or minus 2.093 times whatever I got from my standard error of the x bar. That's how many standard deviations. This is one standard deviation. I want to go 2.093 standard deviations. I know that the middle is x bar, so I'm going to go plus that number and minus that number, and those are going to be my ends of my confidence intervals. Now, the video that I sent out yesterday gives some numbers to this so you can see it. But I think one of the main things I'm trying to get across in doing this for you today is the difference between what happens when we find a confidence interval, where it might be confidence interval, and when we find a p-value test of significance. So we're not quite there yet. If I was doing so everybody okay with this so far? Yes, okay. If I was doing a confidence interval for a categorical variable, the difference is going to be that for a categorical variable, it's going to be p hat, which is my center, just like x bar was my center here. P hat is my center for a categorical variable, plus or minus z asterisk times the standard error of a proportion. And the standard error for a proportion, this is how we find it. This is how we find the standard error for a mean. This is how we find the standard error for a proportion. For a proportion, I am using inverse norm. So let's just take a look here. Second distribution. I'm using inverse norm, which is the normal model, which is z-scores, not t-scores. Okay, is that relatively clear? Something that you can go back to and look at and then say, oh yeah, now I remember how that works. Okay, so this is not a complete waste of time. It's kind of helpful. Yes, okay, great. All right.
Oh, Mr. Jenkins, I do have a question.
Yes.
Can you go over how you got 97.5 again? Like, I get how it looks. I got the 50%.
Mm-hmm.
Oh, on the confidence interval.
Mm-hmm.
How'd you get the 47.5 again?
So 95%, you can see that I want to go from here to here, right?
Yeah.
So 95 divided by 2 is 47.5 on either side, right?
Uh-huh.
Because 47.5 times 2 is 95, and it's symmetric. So I have 47.5 that way and 47.5 that way.
Oh, okay.
Right? But if I'm finding the percentile, really, I start at 0, and I go 0 to the middle is 50, and then add this 47.5, and that takes me to the 97.5.
Oh, okay. Thank you.
Okay, good. All right. So the big difference between confidence intervals and tests of significance when you're drawing the picture, and as you know, I'm quite enamored of drawing pictures, is that when I'm doing a test of significance and I'm trying to find the p-value, in the middle is what I'm assuming my h sub 0, which is either going to be for a quantitative variable is going to be the population mean that I'm assuming, which is mu, or for a proportion would be the population proportion that I'm assuming, which is pi. So this is where the difference comes in, is what am I putting in the middle? And then, well, yeah, because in the middle for a confidence interval, I'm putting the data that I have and I'm trying to find out where do I think mu and pi exist. For a test of significance, I'm saying, well, I'm assuming my null hypothesis is either mu or pi, depending upon whether it's quantitative or categorical. And I will have a test, I will have a number that I got, and I'm trying to see whether or not I am within the test of significance alpha, which, you know, in some cases, you know, it can be 0.1, it can be 0.05, it can be 0.01, it can be many different things. So in the middle is my population parameter that I'm assuming, and then what I'm looking at is, well, let's say that I'm going to use a quantitative variable here. Let's say that my x bar is over here. So my x bar is less than what I'm assuming is the population proportion. Everybody still with me? Okay. So I need to find out, well, how many standard deviations is this away from the mean? Right. If I can find out how many standard deviations, or because we only have standard error, we have to use standard error, I'm trying to find out how many standard errors this is away from the mean. Then what I'm trying to find out for a p-value is, well, how big is this little piece over here? If this little piece is, this is my p-value. If this little piece right here is really tiny, then what it's saying is that it's very unlikely that I could have gotten this statistic from my data if this was really the population mean. It's just too small of a probability to get this if this is the population mean. So if I have a very small p-value, it's saying, nah, I think I'm going to reject my null hypothesis. This is not really the mean. If I got, let's say that my test statistic was really way over here, my mean of my sample, and I had this whole big thing here as my p-value. Well, I'm saying, well, you know, if this is the actual population mean, yeah, it's not so crazy that I could get this for my random sample. You know, I mean, there's a decent probability that I could get that. So I cannot reject this. Am I kind of making sense here? Yes.
I'm confused.
Explain where, Bella.
I got where you said up to like the red X bar, how that was like the real mean. And how everything left to that is the p-value.
Yes.
And how you're supposed, the goal is to find the standard deviations to that mean.
Yes.
Then you lost me after that.
So what I did after that was I said, if the p-value is really small, so if this is a lot of standard deviations away from the mean, can you see then that my p-value is going to be really small? Can you see that? Yeah. All right. But let's say it turns out that my actual statistic, my actual mean from my sample is not that far away from the mean, right? Okay. And my p-value is a much bigger area here.
Okay. Is that still the value?
I can't reject the null hypothesis. Because this could very well have happened just by random chance.
Okay.
Kind of?
I think I get it.
Come talk to me on a different Zoom and we'll do it and I'll go over it with you one-on-one.
Okay.
Okay. All right. So this is really the main thing I wanted to get across in this, right? But the if I was to make these calculations, if I'm doing it for a mean, then let me see here. Let's get a different color here. My t value is going to be equal to my x bar, that's my sample piece of data, minus my mu, which is what I'm assuming is the null hypothesis, the mean that I'm assuming for the null hypothesis, and that is divided by my standard error. So this should look very similar to z equals y minus y bar over s, except that our y is now what we got as our sample mean. Our mu is the actual population that we're assuming, our null hypothesis. And instead of standard deviation, which we don't really know, what we do have is we do have a standard error for our statistic. I'm going to stop there. I think that gets across the main differences that I wanted to get across. Are we okay with this? Do you think this will be helpful if you review it? So, huh? All right. Well, I gave it a try. It was a good try. All right. So let me. I'm going to